Hi everybody, I'm Ali Tawakoli, and in this tutorial we want to learn about UML. What is it about, why it's useful, and how it helps us to build better software systems. So if you're ready, let's get it started. Alright, so Unified Modeling Language, UML, huh? Well, before we get to that, let's first see for whom this tutorial is. Well, for anyone interested in learning it. I mean, it's better to have a little bit knowledge about object-oriented design, but if you, well, still don't know anything about programming language or OOD, it's still okay. I try to explain everything as simple as possible. Okay, why to learn UML? UML helps you build better software systems. It's like a roadmap that shows you exactly where to go to reach your destination safe and sound. So, what is UML exactly? Well, UML means Unified Modeling Language. It's a graphical way of describing software systems. It is created for anyone who likes to know how the system is processing and from what parts it has been created. No matter what the person's position is, developers, users, business stakeholders, whatever. UML can be used in 2 degrees mainly. UML sketching, good for users and business stakeholders to see what are the system's requirements in overall, and UML blueprint, which is good for developers to see how the system is going to work technically and in details. Before we go any further with UML, let's first see how to start a project. We have actually 2 software development processes. The first one is waterfall, which is the traditional way of developing a product, which you will do these 4 steps one by one: analyze, design, code, and test. You will complete each step before starting the other one. Well, what is the problem with this process? If anything happens at the middle of the way, you will face huge problems. What is the next process? It is called iterative. This process is the most common and is actually the modern way of developing a system. So you first define different pieces for your project and then do all of those 4 steps for each piece. So if something actually happens at the middle of the way, you won't face any problems because that issue will affect only one piece of your project and doesn't affect the whole project. So we have also 2 software planning processes. One of them is predictive, which comes with the waterfall process. You know all the project requirements and plan everything at the beginning and then start the project. We have adaptive, which is called agile development, which comes with the iterative process. You work with the users continually, you work with the product owner actually continually to edit the project requirements. So agile development it actually is a really huge topic for itself. I will cover it in another tutorial. Now, from what perspectives should I look at my project? Well, any real-world system is used by different users, developers, testers, business people, etc. So, to build a better product, we should visualize the system from different perspectives. So, we should view our project from logical view, process view, physical view, development view, and the most important one, use case view. So, we have Krachan 4+1 view model, which shows our project from 5 views. Logical view, which shows what a system is made of, and how they interact with each other. Process view, which shows what must happen in our system step by step. And development view, which shows the system parts and how they are organized into modules. Physical view, which shows how abstract parts of the system map into deployed system in real world. I mean how our software system is actually is abstract. So it shows us how it is deployed in a mobile device or a desktop device, etc. So use case view shows shows us what the system must and should do in overall. I mean, what are our project's requirements? So if you're still so vague about all of these views, don't worry. As we go on and continue, you will have a more clear understanding of what these views means. So if you still don't know exactly what do they mean, there's no worries. We will cover them as we go on. So what are diagrams? Well, UML has different types of diagrams that each diagram shows the system from different perspectives. There are two broad categories of diagrams: structural diagrams and behavioral diagrams. So structural diagrams represent the static aspect of the system, such as class diagram represents the object-oriented view of a system. Object diagram, which is an instance of a class diagram, and it's actually a prototype of a system from a practical perspective. Component diagram, when we build our system and create our classes, interfaces, etc., they are all arranged in different groups according to their relationships. So we call these groups our components. Deployment diagram, which shows the nodes that are involved in our software system. By nodes, I mean the physical entities that our component and software system is deployed on. Behavioral diagrams. These diagrams basically capture the dynamic aspect of a system. So, the use case diagram shows us the system's requirements and different functionalities. Sequence diagram. It shows different sequence of calls in a system to perform a specific functionality. Communication diagram. Well, it's somehow like the sequence diagram, but its goal is to represent the structural organization of a system and the messages sent and is received. State machine diagram. Any real-time system has different states that is caused by some kind of internal and external events. So state machine diagram tries to show them. Activity diagram. A system has different activities, and so the activity diagram tries to show us what the system is going to do step by step and in different situations. Well, what are notations? Notations will be used in UML diagrams. They describe the purpose of the model, things, and relationships. Notations are actually the elements that we use in our diagrams. So each notation looks differently, and let's take a look at the most important ones here. Class notation, it looks like this. The name of the class is here. The attributes will be here. Operations will be here. Attributes, we show their visibility like this: public with plus, private with minus, protected like this, package like this. As you can see, the visibility is here. So name is a attribute which is private, and its type is string. So We also can show their multiplicity like this, or unknown number we just put a star like this. So favorite color is a private attribute which its type is color, and it can be from 1 to 5 in the class. It can be initialized 1 to 5. So we can also describe the rules like unique, not unique, ordered, or read-only, whatever. So for example here, the favorite color should only be read-only. I mean, it must be read-only. Friends, for example, is a private attribute which is its type is person. It must be unique, and our person class can have unlimited number of friends. So that's it. Operations are explained like this. For example, here we have a set name operation which is public. It has one argument, name, which its type is a string, and this function or method doesn't return anything. So here we type void, but this operation is going to return something, so we type the type of the class that it is going to return. In our example here, getName method is a public method and is going to return a string attribute. So that is all there is to it about the class notation. Let's take a look at the object notation. Objects notations are like this, and we can also show them like this, and we can show any operation or attribute that in our diagram we think it's important, so we can write it down like this. Interface notation is like this. Collaboration notation is like this. We can also draw additional components to clarify the collaboration responsibility. Use case notation like this. Actor is like this. Initial state notation like this. Final state notation, component notation, and node notation. We show it like that. Interaction notation, which is going to be used in our sequence diagrams. We will show it like that. State machine notations, which shows us how and why a state will be changed to another. We show it like that. Package notation like that. Note notation, and relationships from weaker to the most powerful one. Dependency, association, aggregation, composition, and inheritance. We show them like that. So each notation is categorized in different categories. We have structural notations, behavioral, grouping, annotational, and relationships. So let's take a look at these structural notations. Class notation, as you have seen above, it's actually represents an object. Object notation, the instance of a class. Interface notation is going to describe functionality without implementation. Collaboration notation represents a responsibility. Use case notation, like collaboration notation, is going to represent a responsibility or a requirement, but unlike the collaboration notation, we just write its name and that's it. Actor notation is actually uh, an internal or external entity that interacts with the system. We should actually use it in our use case diagrams. Initial state notation, as I have described earlier, is going to show us how a state can be changed into another state and why it is going to change. Final state notation shows the end of a process. Component notation is actually going to represent any part of this system in our UML diagrams. Any part of the system that we are going to look at it as a module. Node notation, excuse me. Node notation is going to represent a physical part of a system like server, network, etc. Alright, behavioral notations like interaction notation, which is going to explain the different interactions and message exchanges between different participants. State machine notation, which we have explained. Grouping notations, which is only one notation we have here, which is the package notation, which wrap the components of a system into we actually organize our different classes and components based on their relationships into one package. In notational notation, which we have only one notation here, and which is the note notation. It's like a comment in a code. We actually comment any additional description that we like to write down in our diagrams. We write those comments and additional information in a note notation. And relationships. And one thing that I think I have said incorrectly was the initial state notation, which I said the state machine notation, sorry. The initial state notation, unlike the final state notation, shows start of a process, which is going to be used in almost all diagrams. So anyway, let's take a look at the relationships. Dependency notation. It, as its name represents, it actually means that when a class depends on another class. Actually, it shows that a class has an attribute of another class type. So these two classes have dependency relationship. Association notation. A class references another class. Actually, in this kind of relationship, the two classes don't necessarily have attributes that relates them together. For example, teacher and student classes. Although teacher class has no attribute that refer to students, but we do know that in reality, teacher do have students. And this relationship will be more obvious when the school class comes to play. The school class, in our example, has two attributes, teachers and students. And now these two attributes are related to each other. So that's why teacher and student classes have association relationship. Aggregation relationship. It's when a class contains another class. Well, what do I mean by the aggregation relationship? Let me explain it in an example. A classroom has aggregation relationship with chair. So, if classroom is destroyed, the contained class, which is chair, will not. Actually, the classroom owns the chair. So that's it about the aggregation relationship. Now let's take a look at the composition relationship. It's when a class contains another class. What? Is it just like the aggregation relation? No, it is a little bit different. In this relationship, if the container is destroyed, the contained will also be destroyed, like classroom and wall. If classroom is destroyed, wall is also. Actually, wall is part of the classroom. Alright, inheritance relationship, which you might already know if you're a programmer. It's actually a class, when a class extends or implements another class, we call it inheritance relationship. Easy. Actually, the inherited class has all of the parents' attributes and operations. Alright, that's all there is to relationships. Now let's take a look at our next topic, which is what are stereotypes. Stereotypes will be used in UML diagrams. A stereotype actually modifies the meaning of an element in our diagrams. So, for example, this actor. If I write this stereotype for any elements in my diagrams, that element will be known as an actor from now. So it doesn't matter if I have used the actor notation or not. If I write this stereotype for that element, that element will be known as an actor. So imagine you don't even like the actor notation. Easy. You just draw a rectangle and write this stereotype in the rectangle. Bravo! Now that rectangle will be known as an actor in your UML diagrams. And that's it. And UML itself has defined some standard stereotypes that help us to name elements better based on their responsibilities. So stereotypes that are applied to classes, for example, like utility, or which is a utility service, like a math class, for example. The stereotypes that are applied to components like service, subsystem, the ones that are applied to artifacts. By artifacts, I mean files that are used in your software system, files that like exe or txt formats, anything. So the stereotypes for artifacts can be executable, file, library, source, and that's it. So here, let's take a look at another term, which is tagged value. What is a tagged value? Well, your stereotype might need some more explanations, and so you can show that extra information by a tagged value. And in most of the times, a tagged value defines what roles a specific stereotype must obey. So, and how you can draw this stereotype in your diagrams? Well, you can just show it just like how you show notes. I mean, notes notation. It includes the associated stereotype name with the settings of the tagged value. Then will be attached to the stereotyped element using a dotted line with a circle at the element end. And that's it. So, what is OCL? OCL means Object Constraint Language. It helps us express constraints in our models. So, for example, when we would like to define a rule for an attribute of a class, we write this. ID is more than equal than 0. This is a OCL. So Of course, we could also write this rule in a natural language, but as we know, natural language is ambiguous, but OCL is a single formal constraint language, and that's why most of the modelers prefer it. So OCL has 4 built-in types. Boolean, which you obviously know, true or false. Only these 2 values are acceptable. Integer, real, and string. And OCL has also some comparison operators. The ones that are applied to integer and real are these. The ones that are applied to all types are these, equal or not equal. The ones that are applied to Boolean are these, and the ones that are applied to string are these. And there are 3 types of constraints: invariant, precondition, and postcondition. Invariant actually means that the condition must always be true. It's defined on class attributes. Precondition shows that a precondition must be true before a method of a class is executed. Postcondition shows that a postcondition must be true after a method of a class has been executed. It actually shows that the method has done what it's supposed to do correctly or not. So that's it. That's all about OCL, but don't worry, we will see it more when we get to diagrams. You will see how we can use it practically, actually. So let's get to our next topic, which is from which diagram should I get started? So this can be a little bit tricky, especially when you're a newbie in UML. You know, you're still trying to figure out what are all of these diagrams all about, what are their purposes, what are they trying to show me, which diagram I should draw for my project, which one is not necessary, what is the difference between sequence or communication diagram. You know, there are lots of questions that you might have to ask yourself when you're starting to learn UML and using it for the first time. So if you would know from where to get started and which diagram you should draw first, it would be a good guideline for you, especially at the beginning. Although UML does not push any particular system development, but different modelers prefer different orders of drawing the diagrams. So I myself prefer to draw diagrams in the following order: use case, activity, class, object, component, package, interactions diagrams, such as sequence and communication, state machine, and finally deployment. And yeah, for some other projects, I would prefer this order: use case, activity, and the component, and then class, object, package, interactions, state machine, and deployment diagrams. So it actually depends on you and the project that you are working on. It depends on your project. Is it complex? Is it simple? Are you working on a team or not? It actually depends on different parameters. So and actually at the end it depends all on you and how you prefer to draw these diagrams in what order. So that's it. So as the iterative development process and agile development suggests, at the very beginning of your project you define different pieces for your project, like a pizza, and for each piece you will draw all of the needed diagrams, and that's it. You would have a complete roadmap of your project. If you have ever decided to change your project's technology in the future, or needed to upgrade something in it, or even change your developers team totally, there's no worries. You have a complete roadmap of your project. You have documented your project from different perspectives, so you can easily just upgrade your project and change its technology if it is needed without messing up with your project. So, how can I draw such diagrams? The most important question of all time. Well, there are lots of different tools that let you draw UML diagrams, such as UMLet and Star UML and etc. Just search the web and find the one that suits you the most. And yeah, finally, we got to the most important topic of our tutorial: diagrams. We have all of these diagrams and we need to explain them one by one. It's for whom, what is its purpose, what are its most important elements, what points we need to consider, and how to draw them step by step. So that's it about our first UML tutorial, actually the first part. So, and please don't forget to subscribe to be notified of our upcoming video tutorials. So in the next part of the UML tutorial, I will describe and explain the use case diagram. So see you soon.